let's deal with the situation where we've got an inequality, and we touched on this the last day. What's the difficulty with an inequality? It comes in if we are multiplying or dividing by a negative number. And here's the catch. X is a variable. We don't know what value x is, so we don't know whether x plus 2 would be positive or negative. If we just had an equation, we would multiply both sides by x plus 2. I'll write that in. We'd multiply both sides by x plus 2. That would get rid of our fraction, and we'd end up with a quadratic, and life would be simple. We'd just solve for x. But we don't know if that blue writing there is positive or negative, because x could be less than minus 2. We can see in the question, and the restriction we're given is that x can't be equal to minus 2, and x is also a integer. It's going to be a whole number, negative or positive. So we don't know whether what we've multiplied by here is positive or negative. This is a problem because I don't know whether I'm going to flip around my symbol or not, because I don't know whether I'm multiplying or dividing by a negative number. So what can I do that guarantees I'm doing one or the other? I can square it. I can say that instead of multiplying both sides of my equation by x plus 2, I can multiply it by x plus 2 squared. Because regardless of the value of x, if I square my answer, I must get a positive number. So if x was, for instance, minus 10, I would end up with minus 8 in my bracket, but when I square it, I get 64. It doesn't matter that the result in the bracket is negative. I still end up with a positive answer overall. So that's what I'm going to use in order to solve my issue anytime I'm dealing with a rational inequality. Anytime I see a fraction with an inequality, this jumps into my head instantly. So once I've done that, life is fairly straightforward. I'm just going to end up with a quadratic that I'm going to end up solving. In this case, I'll use the minus b formula. So I have x plus 2 to be squared on this side, and I can see I have an x plus 2 on the bottom of my line, so I'm going to immediately divide that out. And I'm left on the left-hand side with x plus 2 on x minus 5, less than 3 on x plus 2 to be squared. Now I need to multiply out my brackets, and I will, when I have done some rearranging, so a little bit of rearranging later that we should all be very able for at this stage. 2x squared plus 15x plus 20. Now I don't have any idea what the factors of that are, so I'm not going to try and do my factorizing here. I'm going to skip on and do the minus b formula. So remember, x is equal to minus b plus or minus square root of b squared minus 4ac all over 2a. This is technically in your log tables, but you really need to know it by heart. And we know that we have this in the correct form. We have a x squared plus b x plus c is equal to 0. And we're pretending this is an equal sign so that we can, again, get our roots of our equation, and then we're going to use a sketch to solve our problem. So we have a is 2, b is 15, c is 20. I have written down the equation I'm going to sub into. I have written down my information. So x is equal to minus 15 plus or minus the square root 15 squared minus 4 times 2 times 20 all over 2 multiplied by a, which is 2. And when I tidy that up a little bit, I get minus 15 plus or minus square root of 65 all over 4. Again, this is just solving a quadratic. You know how to do this, so there's no panic here. Now I want to get my solutions. So I have x is equal to minus 15 plus root 65 all over 4, or x is equal to minus 15 minus root 65 all over 4. And approximately speaking, so I can draw my sketch more easily, that ends up being minus 1.73 approximately and x is equal to minus 5.77. So now I need to keep in mind that I've got restrictions that I was given at the beginning of this question. So I've got a sketch I'm going to draw, and for space's sake, I'm going to write it over here. I am working with 20 being where I cross my y-axis, and I am looking at my roots being around and these do not need to be the most accurate things in the world. They're to give you a feel for what you're doing. So minus 1.75, about where we're going to cross there, and minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, and we're going to cross about there. But we've got a bit of an issue, because we're not dealing with the same type of situation as we dealt with before, where x was an element of or, x here is an element of z. And this is a type of curveball that they can throw you in the exam. Everything so far has been very straightforward. Very straightforward. It's just solving a quadratic. All we need to remember is multiplying by a squared bracket at the beginning, and we know everything else. This is the type of thing that they can throw in, because I know that my integers are only valid when I am dealing with my situations here with whole numbers. So my x values have to be whole numbers. So roughly speaking, my graph is going to look like a smiley face, and I'm going to use a dashed little line as best as I can. I know that my quadratic is going to look something approximately like that, because it's a positive quadratic, so it's going to be a smiley face, and I know that its roots are approximately there. But if I know that it's an integer, then my x values I run into a little bit of difficulty with. I'm looking for where this is greater than 0, so I'm looking for this region out here. I'm looking for where my y values, my y outputs are greater than 0. So I am looking for then when x is going to be greater than my root here and less than my root down here. So that would be x would be greater than minus 1.73, and x would be less than minus 5.77. But because x is not defined for non-whole numbers, I need to change this, because I've got this restriction that x is for integers. So this is where my restrictions come in and are very important. I need to figure out what is the next whole number in both of these cases. So therefore, because x is an element of z, I'm going to need to change this situation here, and I'm going to be looking for where x, what's the next value of x that is greater than minus 1.73? It's going to be minus 1. So x is going to be greater than minus 1, and x is going to be less than minus 6. So that is going to be the restrictions that I've got. So you can see here, I deliberately did this question this way to highlight something that's critical for exams. If they give you a restriction like this in the question at the beginning, it's almost certainly going to come back and be relevant when we get down to the bottom, when we're picking what answers are valid, or what ways we need to change our answers. So the fact that we were told at the beginning that x must be an integer comes back at the end and means that if we didn't meet this restriction, we'd lose 2 or 3 marks at the end of our question. That's significant. It means we go from 10 marks to 8 or to 7, We don't want to do all the hard work and then miss those marks at the end. So from the beginning, I'm talking to you about if we see restrictions, we're going to take them into account. We're going to make sure that we have them noted and that we come back to them at the end and check that our answers meet the criteria that we're required to work with. And that's what we need for right now.